So apparently my camera stopped in the middle of the last recording, so that means all the load testing I did was worthless because it doesn't mean anything now. I have to redo it all. Luckily it's easy to do. So 1 ohm rheostat, 15 volt modified 75 amp power supply. It's 75 amps at most. This meter is inaccurate. I had to do all my measurements with a calibrated current meter. This can be the input or output voltage. I will always let you know beforehand, and that's just, in fact, I don't even need that on right now. I'm just burning out phosphor on my display. Alrighty, let's go ahead and get this testing underway. So the first thing we're going to do is we're going to measure the output. Set current limit. Current limit should be about 55 to 60 amps in the output for transients. So it's a boost supply. It will draw transient load. 24.5, we're going to attach it to a 1 ohm load. It is a 1 ohm rheostat. 1 ohm. That's a commendable voltage drop. (26.3) to 24, 26.3 to 24, 26.3 times 24. That's 631 watts. That was from a previous measurement that I took in this video that for some reason my camera just stopped recording. So I'm going to measure the input. That's the input voltage. 13.1 at 56 amps. 13.1 at 56 amps. 13.1 times 56 equals 733. So I'm losing about 100 watts to heat. Now I can guarantee you I'm losing half of that heat in the inductor and the wiring. The rest of it's all switching losses because I'm operating at 45 kilohertz to 60 kilohertz. It will vary depending on the load. It will actually increase as the load. Sorry, it will decrease as the load increases. That way you'll end up burning FETs out due to them being overdriven. Other than that though, it handles the power. We're going to go ahead and knock the voltage down a bit because this is a 30 amp power supply, not a 50 amp power supply. I'm just showing you that it can handle 50 amps if it has to. Oops. Kinda need my output set right there. (30 amps). So that's commendable. It's a 200 millivolt drop under 30 amp input. I'm just gonna leave that run. Not because I suck at doing percentages. I can do vector calculus. For some odd reason I can't do percentages. I'm just lost at it. I don't know why. And don't ask either. It's just how my mind works. The 631 is 733. 631 to 733. That's pretty good. It only uses 16% power to heat. 16%, man. That's 84% efficient. And I guarantee between 80 and 90, like I said. Of course, that video got cut off, so you didn't hear that. So, yeah. It does exactly what I set out to do. Yeah. It is annoying that it does squeal. That if I dip the inductors in resin, they'll stop squealing. So obviously it does a good job. It's more than capable of handling the current, but I actually had it upside down, which means that the fan wasn't running. In fact, it's a worst case scenario. Let's go ahead and take some measurements now. So with the fan facing down, which means it wasn't cooling the heatsink off, we have 125 degrees at most. Which means I technically don't need a heat sink. Which means I technically don't need a fan, but I'm a nice guy and I want to include it just because of the hell that way it actually works. Oh, damn, those connectors are getting nice and toasty. Now, I tested this earlier for an hour straight, 30 amps. I got bored and just turned it off because I wasn't getting over 150 degrees in the inductor, and the MOSFETs weren't getting over 120, which means they're all well within the safe operating limits. They will handle 50 amps momentarily. I don't think you want to try running at 50 amps continuously, although they can and will run 50 amps if you have to. I'm not going to test it any higher than 30 amps because I'm going to burn out my rheostat for one until I rated for 22 amps. Number two, my power supply will pull enough current that it will shut the breaker off to this room, and I can't do any current testing. There's no power coming off the wall, and I'm not really willing to hook this thing up to a battery and do that kind of testing because of the fact that batteries have no current limit, and if I make a mistake on the development board, I can literally have a fire in the house, which I'm not really willing to have happen. Yeah. Sorry about that. I had to go check on something. I let this kind of sit in the freezer, and luckily it did not explode this time. Anyway, so you saw it here. This power supply works wonderfully. It just has a loud squealing noise, sadly, especially when I went from a 0.05 to a 0.01 ohm resistor. It started squealing pretty loudly. That's mainly because it allows more current without being resisted. This right here is technically not a resistor, it's just a piece of nichrome which measures the 0.05. It gets too hot. It gets so hot to the point that the solder on the pins actually melt off. So I can't use those in the final design. I'll actually have to use something like some chassis mount resistors. But I don't want to be using 0.01 because 0.01, well, it'll hit 0.1 volts. Sorry, 1.1 volts on the current sense pin, which will shut the controller off at 100 amps. 0.05 is 25 amps, which is what I need for this, because that means essentially it'll shut the power supply off at 50 amps load, because it's two FETs. And that's a safety feature. That way, if you do try going over 50 amps, it will just shut the supply off entirely for you. And the only way to recover at that point is to take the load off and then take the power off. And that's to protect you and me. Me from liability, and protect you from having a fire in your car, on your roof, wherever you install this thing, really. And generally just to keep your ass happy. Because if it fails, I'd rather it fail safely. I'd rather it fail under controlled conditions. But don't let that fool you though. Nothing will ever come close to using a fuse. You should always use a lovely AGU fuse for this. I had an AGU fuse somewhere, but it's probably packed up in the move. Always use a fuse. Get a 50 or 60 amp fuse. I'd recommend 50 amp, maybe 40 amp. Always go about 10 amps higher than what you're going to be loading it down with. That way, if anything does happen, a peak transient happens, it'll blow the fuse and your power supply is saved. And if you may have noticed that the heads are actually sticking off a little bit, that's acceptable. It's not really considered supreme, but you saw it here, folks. It did just fine without getting too terribly hot. In fact, I'm more worried about the toroidal cores. In fact, sorry, the inductors. I might have to actually put a fan on top of them before I sell, because that's just too hot. I mean, it went up to 200 degrees in one test, and that's just not acceptable. It's going to be not very fun to do, though, because there's really no way I can mount a fan to that. I could just probably pass it on to you, because there's really no need to put a fan on the inductor unless you're loading up to like 50 amps. 30 amps, you don't need to worry about the inductors. They'll get hot, but they won't burn out. They're inductors. They're not going to burn. But you saw it here, though. This is getting 85% efficiency at best under a pretty heavy fucking load. That's under 600 watt load. You're getting pretty efficient. So to recap, you want these? Contact me. I'll build them for you. I mean, I got dozens of these boards just lying around waiting for me to populate them. All I really need are people willing to buy them. And I have an eBay store called Stever9198. It's not really a store, it's just my personal page on eBay. Check that out there. They're gonna pop up there one day, and then this is called the Mark II, by the way. The Mark I is actually this as a test board, and it works fine. But I don't want to sell test boards. I want to sell complete assembled units ready to ship out. The Mark III that I'm working on over here uses a 200 amp core. I need to actually find different cores though, because I had to physically gap these cores. These are ferrite, and I had to gap it so that way I can get the reluctance down. Sorry, the reluctance up and the inductance down. But there's some iffy things I got to work on it though. It's not stable with that core, so I got to work on it. Obviously, it's not ready yet. So we're good. Everything works the way I wanted it to.